welcome back to the classroom. This is Mr. Wong. In today's lesson, we're going to be looking at different types of compounds, in specific covalent bonds and covalent compounds. Okay, so part of the lesson, we're going to look at the requirements, the chemical requirements to make a covalent compound. What is a covalent compound, and how do the electrons interact during a covalent compound? What you should be able to achieve by the end of this lesson is naming specific covalent compounds, the naming conventions, and also work out the chemical formula of the covalent compounds as well. Alright, so something that's slightly different, if you recall, ionic compounds. This occurs when there is a trading of valence electrons. So you can see in this animation here, the sodium gives its electron to fluorine to obtain a full outer shell. So in ionic compounds, we are donating electrons from one ion to another, or from one atom to another atom. You can see here that ionic compounds are formed from the combination of metals and non-metals. So we could have anything in the red here forming with anything in the blue here, and that would produce our ionic compound. We already know some examples of ionic compounds, so sodium chloride, that's your table salt. Calcium carbonate, that's your lime water. Let's have a look at covalent compounds and see where the major difference is. Well, firstly, you might actually notice is the naming conventions. So we have dihydrogen monoxide, which is water. We have carbon dioxide, which is one of the famous greenhouse gases that we know of. It has some interesting naming conventions. As you can see here with dihydrogen monoxide, a lot of people do get confused when they hear the chemical names of covalent compounds, just because it does sound very different. And so we have things where we call the dihydrogen monoxide hoax, basically using the concept of water, facts that we know about water, using its chemical name, and essentially tricking people into thinking that it's a really deadly liquid. So you could see all these facts here are indeed true, but obviously there are some sort of choices made and picking and choosing between the facts. So fact one, 100% of people exposed to dihydrogen monoxide will die. If you are exposed to water, obviously. Fact number 5, cancer tumors contain a large fraction of dihydrogen monoxide. That's also true as well. So we're going to look at how we name covalent compounds, and also how do we form covalent compounds. Another example of covalent compounds is nitrogen dioxide. So for those of you who can see the Harbour Bridge, every day during peak hour traffic, a lot of combustible engines will release this sort of brown gas called nitrogen dioxide, and it's just this kind of brown haze that you see at peak hour here. Alright, so let's understand the language when we talk about covalent compounds. So co stands for sharing, valent means valence electrons. So when we talk about covalent bonds, we're talking about chemical bonds formed by sharing valence electrons. So you can see we have two hydrogen atoms here. Both have one valence electron. Now, if you're in the second shell, or in the first row, so in the first row, so in row number 1, row 1, you can have a maximum of 2 valence electrons. Okay, so what the two hydrogens do is they form a bond by sharing their valence electrons. You can see here in the outer shell of the two hydrogens, the electrons are essentially looping on both sides of the valence shell. So they're being shared between the two. If you compare that to ionic compounds, where they just give it to one side and take nothing from it, you can see there is a major difference. Okay, so that's what we mean by covalent compounds. It's when we see this sort of sharing process of valence electrons in the valence shells of two or more atoms. Another thing to keep in mind is that covalent bonds only form between non-metals. Okay, so covalent bonding only occurs for non-metals. And sometimes we can represent these bonds using what we call Lewis dot diagrams, which which is drawing out the valence electrons of the specific atom we're trying to look at to show the bonds, the covalent bonds that we form. So these are three common ways we can show for the covalent bond. You can draw a line to represent the bond. You can draw a dot and a cross diagram or a Lewis dot diagram. Either one is correct. Lewis dot is the one that people tend to use more often though. Okay, so just remember what we define as a covalent compound is when two or more non-metals, so if it's a metal involved, it cannot be covalent compound, it'll be ionic. So only when you have two or more non-metals combining through sharing their valence electrons with each other. Okay, this forms our covalent bonds. This follows what we call the octet rule, which states that the valence shell is completely filled and the compound is stable. So using the example of carbon and hydrogen, we know that hydrogen needs two valence electrons to make a complete full outer shell. So you can see that each hydrogen here has two electrons in its valence shell here. If you also look at the positioning of carbon on the periodic table, carbon is in group 4, which means it can take in, so it needs an additional 4 electrons to obtain a full outer shell. And you can see what's happening here is the hydrogen is, or the 4 hydrogens are each contributing 1 additional valence electron to orbit around carbon here. So that's just how the valence shell is occurring. You can also see the actual structure or the chemical formula of this particular compound would be CH4, the 4 representing the 4 hydrogens, the C representing the 1 carbon that we have in this diagram here. This is actually also known as methane, another type of greenhouse gas. Okay, so how do we work out how reactive something is? There are 2 groups on the periodic table. Group 1, anything in group 1 is incredibly reactive. So in terms of metals, group 1 has the most reactive metals. In group 17, or group 7, sometimes they call it, we have what we call the halogens. They're the most reactive non-metals. And it's sort of this ability of these group 17 elements to extract electrons or bring electrons closer to themselves that causes this incredibly high reactiveness. What we know about in terms of chemical properties of covalent compounds, they will exist as gases, liquids, and solids, but they have a really low melting point. So in comparison to the ionic, in comparison to the bond strength with ionic bonds, covalent bonds are weaker than ionic bonds. They do not conduct electricity because they do not form ions. Okay, so anything that's a covalent compound will not conduct electricity. For example, sugar is a type of covalent compound. It's made out of carbon, hydrogen, and oxygen. All three are non-metals, so they do not conduct electricity, and they're usually insoluble, so they can't dissolve in water very well. That's what I mean. Those are the chemical properties that we're talking about when it comes to covalent compounds. Okay? The next thing we have is the naming conventions of covalent compounds. So, keep this in mind. When you're writing the name of a covalent compound, the element that appears closest to the left-hand side of the periodic table is always written first. So if you have a look at your periodic table, nitrogen is further to the left than oxygen, and hydrogen is sort of between them. So nitrogen would be written first, and then oxygen if you were trying to write the name for such things. So when it comes to the name, the second element, you'll have to write it similar to you trying to write an anion for non-metal. So you add IDE at the end. Might just make this a little bit more obvious. So you add IDE at the end, and you take away some of the first words. Okay, we will need to use what we call prefix to indicate the number of atoms present, but if your first element is singular, there is no prefix required. So let's use the example that we have here. We have C and O. Capital C is carbon, capital O is oxygen. We did say that a single element at the front doesn't need a prefix, but the second letter or the third letter will need a prefix if its own will need a prefix regardless. So one, the prefix we use is mono, so we say carbon monoxide. Another example we can use is carbon dioxide, which is CO2. You can see this one here, we only have one carbon, hence there's no prefix. And then oxygen, there's two of them. The prefix we're using is di, and so oxide. Okay, this is how we do the naming. Now obviously I don't expect no one expects people to remember what the prefix are without knowing what the names are. So let's have a look at the different types. Okay, so these are all the different types of naming prefixes. So if you have one atom, it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is decta. So this is using the Greek, I think, annotations for it. And obviously if you know your shapes like hexane, octagon, hexagon, pentagon, you should be able to remember this by itself. So we've already done the first one. Let me go through some of these and let's see what namings can you come up with. So here we have is nitrogen. So we have nitrogen triiodide. That is the name of the molecule we have here. Next we have here is silicon. We have chlorine, which we will rename into chloride. So you can see it's chlorine here. We need to get rid of the last few letters. Change it to chloride. So there's 4, so it is silicon tetrachloride. We have nitrogen here, we have oxygen here. Now notice that there is a 2 in front of the nitrogen, which means we will need to add a prefix. And so we're going to call this dinitrogen trioxide. Okay, the next one we have here is dihydrogen monosulfide. This one we have is nitrogen trihydride. You'll actually find a different name for this on the internet. Usually they call this ammonia, and it's actually a cleaning reagent that people use. As a matter of fact, the ancient Romans in Pompeii and Herculaneum used ammonium to do their laundry. It's a really potent smell, so it's not very pleasant as well. The next one we have here, we already said, this is carbon tetrahydride, also known as methane, a very powerful or a very strong, well, strong is not the right word, but it's a greenhouse gas that can absorb more heat than carbon dioxide. The last one we have is disilicon decafluoride. Okay, so that's how you do the naming systems of these covalent compounds. And as you can see, that should be disulfur. My apologies. Silicon is Si. Okay. The next one you'll need to work out is obviously to go work backwards. If you're given the name, how do you write the formula? So you will need a periodic table to do this. Firstly, we have hydrogen, which is H. We have chloride, which is Cl. Mono means one, so HCl1. Same idea as just saying writing HCl. This is known as hydrochloric acid, and it's a really, really strong acid. It's actually one of the acids in your stomach that's used to break down food. Next one we have is bromine and dichloride. So bromine is Br, chloride is Cl, and we have two of them. So there's that. We have sulfur, chloride, 4 of those. So that's how you do these naming and writing the formulas of covalent compounds. Remember though, the major difference with ionic compounds, so ionic compounds don't use prefixes, okay? So if you do come across any ionic compound, you won't need to call it mono, di, tri, or tetra. That's not required. Okay. Alright, so that kind of ends what we need to talk about with covalent compounds. The major thing you need to remember and to keep in mind is if it's a covalent compound, so covalent compound or covalent bond occurs from sharing valence electrons, so sharing valence electrons by non-metals. You'll also need to remember how to write the name. Okay, so you also need to know how to name a covalent compound. And to name a covalent compound, you need to know the relevant prefixes. So keep that in mind. Okay. Alright, so thank you for watching this video. Hopefully this was of help to you. If you do need any other assistance, always just rewatch the video or ask it in the comments below as well.